Hello everyone, welcome to this lecture 2 of the third unit, that is on the bridge engineering. In the previous class we studied about the what is basically a bridge is and in which branch it deals with, and also we studied about what are the its various components of bridge. Right, a bridge is a huge structure, so what are its components? We saw some of the bridges also, some of the fine examples of the bridges in India, right? So now today we are going to go into the deep definitions and terminologies that we are going to use in the bridge engineering, right? Right, terms used in the bridge engineering: waterway, flex, economical span of bridge, scoring, freeboard. Right. Now the first one is waterway. Right. If you see this image, this is a bridge, right? Can you see this part? This is road. Can you see this road? This road which is connecting the bridge. In this side also it is there, right? This is called as approach. It is called as approach, right? This road which is connecting the bridge, right? And this is your obstruction to this bridge. Now what we have done is we have raised this height, right? Here also in this side also we have raised it. Why? It was actually at this level, at the ground, at the level of water here. Why we have raised it? So that we so that we can increase the height of the bridge, of the road, so that it is at the level of the bridge. The level of the bridge and the road should be same, right? Once it is same, right? Once it is same, we can connect it easily. And can you see this sloped embankment here? This part, and it has some greenery over it. The plants, small shrubs are being planted, grasses are being put it over. Why it is done? Because during the rainy season, right? Whatever water falls from this embankment slope, right, comes into the channel in this side. So it should not carry soil with it, right? So that it should not carry the soil with it, we uh, plant grasses over the sloped surfaces, right? So these sloped surfaces, uh, once been provided with grasses and the small plants, this will hold the soil and not allow the soil to move with along with the water. So this type of protecting is comes under the ancillary works, right? That comes under the ancillary works or the protective works. Now coming to the main part, this is what is I told you I will tell you in the next class, right? So that is what is ancillary work. Now we'll come to the waterway, right? Let's look at this. Look at this image, right? Can you see the waterway? Right, this is your waterway, the passage or a channel through which the water flows, right? Above which we construct a bridge. That area is called as waterway, right? It is called as waterway. The area, the area or a passage through which the water flows under the bridge superstructure is called as waterway. The flow of water in this direction below the bridge, right? It is not all along the bridge, across the bridge. It is at some portion of the bridge under which the water is flowing. And actually bridge starts from this point to this point, but the waterway is for a very small portion of the bridge, right? So that portion is called as waterway, right? Next is afflux. Now what is this afflux, right? See this image. Okay, see this first image. Once we construct the bridge across the river, in the case of river we are talking about, right? And when the flow of direction of water is in this direction, as the water comes nearer to the bridge, right, as the water comes nearer to the bridge, see at this drawing, the water level will start increasing, right? It will start increasing. Why it will increasing? Because actual width of the waterway is this, right? Due to the construction, right, due to the construction of bridge, that waterway has reduced, right? So you can see the water is coming through only these two openings, right? Can you see here? So we have reduced it, we have blocked the passage of water. So due to that, as the river water comes nearer to the bridge, the water level the water level will slightly increase at certain distance away from the bridge. At some distance away from the bridge, right, there is a rise in water level. This rise in water level near the bridge, okay, is called as what? Afflux, or it is also called as backwater, because it is back of the bridge. Water which is behind the bridge is called backwater bridge, right? So it is called backwater or afflux. This rise in the water level. When the bridge is constructed, the structures such as abutment, pier, right, abutment pier causes a reduction in the natural waterway. So due to this is the increase in the water level, right? So that increase in the water level and the reduction in the natural waterway, that is called as afflux or backwater. It is called as afflux or backwater. So whatever I try to told you through this image, it is the same thing written here. Okay. Next is economical span of bridge. It is economical span. Now what is span? Between the two supports, the length of the bridge between the two supports, right? This is a one support and this is another support, and the distance between these two supports, the length is called as effective span or effective length of the bridge, right? Now how to decide whether which span is to be taken and what distance should be taken of each span, right, and which is economical for that type of bridge. Depending upon the length of the bridge, it depends upon the type of material which is used, it depends upon the type of construction materials that is been used, it depends upon the natural temperature variations and also geographical conditions, right? Depending upon all such conditions, it depends, right? For now we can understand that the economical span of the bridge is that span of the bridge, the total cost of the bridge will be minimum. Okay, the total cost of the bridge will be minimum for that span. For whichever span we have the less total cost, as total cost reduces, total span is very less and it is economical, then that type of span is called as economical span of bridge. For any span which minimizes the total cost of construction, that span is called as economical span of bridge. Next is scoring. What is scoring? Before uh, telling you what is coring, can you see this part, this bridge, right? And the difference between here, these two foundations of the bridge. This is actually a pier, and this is called as pier cap, right? And this is pile foundation. It is called as pile foundation. Right? It is pile foundations. If you see the first image, what I try to show you, this image, below this pile cap, this is called as pile cap, right? Can you see here the pile cap? Below there is a piles, right? But you are not able to see it. Why? Because there is a soil around it. There are stones, rocks, and soil around it, right? Why it is not there in this case? Because due to the flow of water, the velocity of the flow of water, what has happened is along the long period of time, the uh, water has taken away the soil along it. Slowly along the years, the water which was flowing below the bridge has taken the soil with it. So due to what is happening, the there is a reduction in the soil quantity at the foundation. If the foundation which was should be actually below the ground, it is now above the ground, and it is in contact with the atmosphere. So due to the alternate drying and wetting, because as it comes in contact with the uh, atmosphere, it comes in contact with the sun. So due to the alternate drying and wetting of the foundations, and due to the other weathering actions, what happens is there is a weakening of the foundations. So this removing of the soil from the bed of the river, which will lead to the uh, bringing the foundations into the air or the atmosphere, is called as scoring. Removing or deepening the river bed, right, due to the taking away the riverbed soil along with it, that is called as scoring. Deepening or taking away the soil, that is called as scoring. You can see in this image what is scoring exactly is, and what causes, what problems it might cause. Next one is the freeboard. Before going to the definition, we'll understand here in this image. I have shown the two markings here, right? This is the water level, and this part is the bottom surface of the superstructure. This is a superstructure, right? So the below portion or the bottom portion of the, it is a bottom portion of the bridge. So the distance, right, the distance between the bottom surface of the bridge to the top surface of the water, that is called as freeboard. The gap which is provided between the water and the bridge, right, the bottom portion of the bridge, the gap that is provided, that gap is called as what? Is called as freeboard. It is called as freeboard. It is called as freeboard, right? So these are some of the freeboards depending upon the type of bridge, right? For arch bridge it is okay. For arch bridge it is 300 mm, that is 30 centimeters. For girder bridges it is around 600 to 900. Navigable bridges, where we allow the movement of boats and ships for the transportation purposes. In that case, we have constructed the bridge at that point where there is a lot of movement of sea movement, sea traffic movements. So in that case, we require a navigable bridge where the space between the bridge and the water should be so high that ships and the boats can move below the bridge. Right. Next is high level bridge where the freeboard is around 600 mm or 60 centimeters. Right. These are some of the freeboards that we use in the actual scenarios. So this is all about today's class. We studied about the components. We studied about the terms today, which are the different terms that we are going to use in the bridge engineering. These 5 terms are very important with respect to your exam point of view. This is asked in every alternate papers for 5 marks. 5 definitions, 5 marks. They don't ask explanations, they ask only the definition. So please remember the definitions. First understand the definitions, it's well and enough to get you the 5 marks. Right?